So this video is going to cover chapter 14 of geometry. It's going to go from 14.1 to 14.4. By the end of this video, you should know what deductive reasoning is and how to use it. So deductive reasoning is also called logical reasoning. And it's the process of demonstrating that if certain statements are accepted as true, then other statements can be shown to follow from them. So essentially, if we have a statement and we say that this is true, then another statement can be shown to also be true. So a logical argument consists of a set of premises and a conclusion. And then a premise is going to be each given statement. And a conclusion is going to be the statement arrived at through reasoning. An argument is going to be valid if the conclusion has been arrived at through accepted forms of reasoning. So essentially, a valid argument is an accepted argument. And then an invalid argument is if you draw a conclusion by using an unaccepted form of reasoning, then the argument is invalid and may or may not have a true conclusion. Whereas for a valid argument, if all the premises of an argument are true and the argument is valid, then and only then must the conclusion be true. And then an unsound argument is an argument in which one or more of the premises are false, and so it may or may not have a true conclusion. So 1 plus premises false. So to translate an argument into symbolic form, we use capital letters to stand for simple statements that are either true or false. So for example, if I said, if it's raining outside, then I get wet when I go outside, we could translate that, so it's an if-then statement, which is what a conditional statement is, and we can translate that to if P, so P stands for it is raining outside, then Q, I get wet when I go outside. So if it is raining outside, then I get wet when I go outside. And a conditional statement is when you write if P then Q. So it's an if-then statement. So this next term, according to this, if you accept if P then Q as true, and you accept P as true, then you must logically accept Q as true. So a negation is made by placing the word not in the sentence appropriately, or by preceding the sentence with the phrase, it is not the case that. And then the symbolic translation is going to be, so if you have P and you negate P, the negation is going to be not P, creatively. And then a double negation is going to express the negation of a sentence that already contains a negation. So essentially, you just remove the not. And so according to this term, if you accept if P then Q as true, and you accept not Q as true, then you must logically accept not P as true. So we can also use Venn diagrams as a tool for seeing logic statements, for visualizing them. So if we have the statement, if P then Q, we can represent that by drawing a circle for Q, and then drawing a circle within it for P. So this could be for a statement such as, if I have a square, then it is a rectangle. So this could be my square, and this could be the larger category of rectangles. And then if P then not Q is represented as two separate circles. So now we have some more symbols to further simplify these statements. So if we have the statement if P then Q, we can actually further simplify that to just P arrow Q. And then not R is going to be this little squiggly and then R. That means not R.